Hi, I'm Malcolm Harkins, Chief Security and Trust Officer with HiddenLayer. Thanks for joining us today so we can have a discussion on how to build secure agents. We're going to talk around a wide variety of things. If you have questions, please put them in the question box. We'll leave some time at the end, but we may cherry pick a few along the way as well. Excited to get going. Excited to have Jason and Kasimir with me. Once again, we've done this a couple times before, and I think you'll find that our questions, the banter, our perspectives, hopefully will be valuable for everybody, given our respective backgrounds and certainly Kasimir and Jason's technical acumen. Hey, so let's just jump into this. Hey, so let's start with a little bit of strategic framing on why this really matters now. Hey, how is agentic AI fundamentally different from traditional AI deployments? Jason, do you want to start and do some framing?
Yeah, I mean, I think the name agentic applies agency, right? And so what we're seeing is instead of this sort of reactive AI system that you might get from a chatbot or something like that, agents really can take action. They can do so autonomously. And that itself means that decisions, controls, and attack surface can happen autonomously as well. And of course, the agency is coupled with the capability that these models that are driving these agents have gained over really on this exponential curve over the last couple of years. So what they can accomplish really has expanded greatly. And so the question comes down, who are they loyal to? Like what, are these good employees or are these insider threats or what, how are what's going to happen with them? That's really what's changing in front of us.
Cool. Hey, and Kasimir, with that, kind of the new categories in essence of risk, or maybe they're not new categories, they're just the same categories of risk, but they're actioned or attacked differently, considering that autonomy. How do you think that cascades into risk conditions for an organization? Given some of the agentic things that we've seen from companies or stuff you've worked on.
Yeah, so I would say a lot of it is actually the old categories that we saw. There are one or two new categories, but it's not as much as you'd expect. Some of the new categories are how to design an agentic system, but that comes down to traditional coding practices. Or maybe there's a new vulnerability category that can hit slightly differently. That I think actually the webinar, the second part of the series, will talk about some of those as well. But overall, most of it's the same. Jason has a quote that I actually like a lot of, a lot of this is you have an agent that's in your system. It's an insider threat potentially, but that's something that traditionally you might still have an insider threat. You would stop that with something like an interview. And I know, Jason, sorry for butchering your quote there. But, how do we interview these AI agents that are inside of our system? And then I also want to say, Jason did a great job touching on, the differences between agentic AI and traditional AI. And then I just wanted to add one more component to that from a security standpoint, from a security perspective, there's also this difference now where we feel the impact a lot differently. I know for a long time, the impact was, so what if a chatbot says something it's not supposed to say? I know, Malcolm, you and I have talked about this on and off camera quite a bit, but with, agentic, now it can delete files. We've seen all over the news of, chatbots and agentic agents deleting files, might give you documents. It has access to actually do things. So it changes the whole scope of it all, even though it is still the same risks we've seen before.
No, well, and I think you bring a great point. It's not only do we have, in essence, that expanded attack surface because of the new capabilities, the attack depth and impact and blast radius, given the decisions on autonomy, is both things are expanding. Am I correct in that assessment? The surface as well as the depth, and then the blast radius moving from, again, a simple chat bot to something that's agentic, that's making decisions or connected to some business process.
Yeah, I think you'd see things like right? The attack surface is changing because of the interface that we have with these agents and the kinds of data that are going in and out. The use cases are changing because they're being put into more autonomous scenarios, that are typically driven by humans. Instead, they're being driven by this agent and supervised by humans. That's a fundamental shift. And then what the agents are able to do, like Kaz was talking about, they're managing file systems, they're reviewing code commits, they're looking up records in databases. Like these are all being done autonomously. And so all of those three things are shifting what an attacker objective might target in terms of a security perspective. They're also, I mean, we should acknowledge they're shifting, in useful ways. Like they're being deployed because they fulfill needs that are really helping companies and enterprises get work done at a new pace. And the pace is probably something we're talking about too.
Yeah. Well, Cass, is this just an overprivileged problem? We've overprivileged the agents in some way?
So a lot of it is, privilege is a big part of it. However, with security, there's always that line between usability and security. And I would say in the way that we want these agents to work, again, going to Jason's words, we all want our own personal Jarvis. At that point, you do have to have some sort of privilege. And a lot of times we want these agents to act like a person in our company. So we have to give them the same privileges as a person in our company. And that's where, actually designing them securely and designing them in ways so that there's minimizing the impact while still having that usability, which is stuff that we've already been doing for a long time with traditional security.
That makes sense. And you brought up a good point around design. What are the, Jason, I'll start with you, and then Cass, you kind of round it out as well. What are the most common design flaws? Insecure decisions, that we've seen, and how many of those are in essence repeated from what we saw with, I'll say, more basic AI that are now maybe getting compounded as we move into this autonomy and agentic AI capability.
Yeah, when you look back at kind of the first round of chatbots and those kinds of things, there was a lot of focus on jailbreaks and prompt injection attacks, these direct sort of prompt injections, right? So you're typing something into a chat field and you're getting it to say something, maybe it shouldn't, maybe it's offensive, maybe it's answering the question in a misleading way, those types of things. Those fundamentally still exist in the models. And so what that means when you apply it to agentic is that the control over the flow, if you want to think of this in a more software sort of sense, of the agent is still under the control of this textual input, these natural language inputs or code, or there's actually a lot more stuff being fed into them now as part of agentic, right? And that is mixing that control flow, like what actions should this agent take, with the data that it's processing. That's where the term prompt injection even comes from, right? You're inserting instructions into a data flow as part of that, and that remains like the most fundamental piece that we're seeing in these agents. It's an attack vector you don't really have with other types of software. Because you have control flow issues with other types of software, but they take much more structured forms, buffer overflows or CSRF, or name your favorite type of classic input validation problem. How do you validate natural language is a big part of my day job, and Kaz, your day job, but I think that's a big part of it. There are efforts that have been made by the model providers. So there's something that's called the instruction hierarchy. We've talked about it on here before. Instruction hierarchy says, these instructions should supersede these instructions. So typically an application has something called a system prompt or developer prompt, depending on which model you're using. And that establishes the persona, the purpose, the scope of the agent, right? There may be more than one that gets into some of the more complex agentic systems, but at its core, there's one of these. It says, for this flow, here's what you are and are not supposed to do. And then there's user instructions, which are what you think of as prompts. You type them in. They can come from other sources too, but that's loosely. And then with agentic, because they can call tools, that's a core function of how they're able to interact with the world. That is another level in that instruction hierarchy. This was set up by OpenAI originally. It's adopted by pretty much all the providers. Now, this is trained into the model. There's no hard constraints. The model's by design meant to mix information. That's what they're supposed to do, is take information from multiple sources and produce outputs from it. And so that mixing is really non-deterministic. And that's a big part of what we see when we're doing prompt injections, is that we can mix the information in a way such that the model follows the wrong set of instructions. You might call it gullible, I guess. It's social engineering for classic,
Yeah, well, and again, you talk about all these design things, and I think again, like I said, the foundational model providers have been doing that. We see NIST, risk management framework, ISO 42001, all those things that are a good design guidelines and principles and stuff like that, and creating that instruction hierarchy, internal policy constraints, so that models are, and the actions they're taking are fair, and meet all the ethical boundaries and legal boundaries, stuff like that. Cass, is that, that's certainly necessary, but is that sufficient control, considering the ways in which models operate? Is that just good enough? Is that all I need to do, is put the right constraints and instruction sets to control the model and what it's doing?
Yeah, well, I guess, Malcolm, I'm going to actually ask you a question to get started for this. If I give you the safest programming language in the world and tell you to create an app that lets somebody put in anything they want on a command prompt, is that safe?
Absolutely not.
Right.
Though, again, this is where it's interesting, right? Because I think people sometimes misperceive what a control does and doesn't do, and I think you made a great thing on it. It provides some level of control, but again, it can be abused because it's not, the control itself isn't protected. Am I interpreting this correctly?
Yeah, exactly. So we're seeing the same thing. So all of these, state-of-the-art model providers are adding all of these different controls to try to prevent prompt injections, to reduce the impact of them. Adding the different stages with the instruction hierarchy, that a user can't overwrite a system. The tool shouldn't be able to overwrite the user or the system, especially with how we're using these agentic systems. However, people are still, or developers and a lot of the vibe-coded apps out there, are still building these agentic systems in ways that, even with those protections, they're still vulnerable, or they're building them with designs that actually turn off the protections that are there for them.
So if I wanted to, again, I'm working in a company and I'm wanting to do vibe coding and do some of that stuff. What should I be considering? What steps should I take besides those, instruction hierarchies and policies within the model? What else can I do? Or what should I go talk to my security team to go ask for their help to figure out ways for enhanced protection?
Yeah, so there's a lot of common patterns that we see. So I'm the director of our security research team. Jason's the adversarial machine learning team. My job is to go and just try to find stuff to hack. So look at all the agentic projects, see how we can hack them, how we can use prompt injections that Jason's team comes up with, like these really cool new ways to do prompt injections. How can we actually make them actionable in the real world? And while doing that, we've come across several design patterns that, having built my own agents as well, I can see why people do them, because they make it easier to build the agent. However, those end up being patterns that turn off security, even if you do have a guardrail. So I would say, as a security practitioner, I would go through and make sure my developers aren't doing some of these things. And there's quite a few of them, but I was going to go over some of the main ones. I'll give a brief overview.
Before you do that, let me ask a clarifying question. instruction, controls and constraints, are those the same things as a guardrail?
No,
Or are they different?
those are different. Jason, since I said your team is doing prompt injections, you might be able to explain that pretty well.
Yeah, so the hierarchy, alignment, if you've heard that phrase, RLHF and other forms of like fine tuning that are done. These are done by the model providers in order to try to constrain what the model's willing to do. And a way to think of it is you start by training this model on vast amounts of data. So it just learns everything about that data, right? And then you go and you say, all right, now that you've learned all of that, here's what I want you to be able to say. And so you teach it to kind of hold its tongue, if you will. But it still knows all that information. It still knows everything that it was pre-trained on. And so you're teaching it, don't say this. And then, so the type of work that we do, these jailbreaks, these instruction hierarchy bypasses or prompt injections, are trying to find the ways to kind of get around that. What we see in the agents, right, Kaz, is there's a lot of these agents that attempt to enforce policy with the model itself, right? So they take in a prompt that says, don't talk about Bruno, right? And so the model's like, okay, I won't talk about Bruno, but then the prompt injection type techniques that we've come up with in our ape taxonomy has a whole list of them. We got like 50 some odd different tactics.
And ape, for just folks, is our adversarial prompt engineering taxonomy.
Right.
Yep.
Yeah, so it's kind of this structured tree of tactics, techniques, and prompts, TTPs, that we've come up with for how you sort of evade any of these controls that are built into the model. So guardrails are outside of that. They're sort of Malcolm, you and I are definitely old enough for security monitors, right? That terminology. So they sit outside and they attempt to determine whether the model is doing the right thing independent of the model. Sometimes they're called firewalls. Sometimes they're called detection and response engines. There's a few different names for them.
Okay, so the instruction set, those constraints are, again, internal to the model. They're designed in, part of the training and all that stuff. Then I release it.
Self-enforcing, right? They're self-enforcing. That's an important part of it.
Thank you for that. And then the guardrails are basically a bumper, a basic runtime protection that then encapsulates to some extent the model to also make sure things are within parameters. And then, do I need anything more than that? Is that sufficient? And maybe, Kasimir, go back to some of your examples, and then we can determine where sufficiency of control lies between what's in the model, that basic thing around the model, and maybe other things that I might need to do.
Yeah. So Jason actually mentioned one of the first system design flaws that I wanted to talk about briefly, which is that there's this over-reliance on the models to do all the security. So a lot of developers either don't have the time, don't have the manpower to actually build out code controls. How would you stop the model from talking about Bruno? What if I get the model to talk about Bruno, but put a space between each letter, or I'll put it as base 64? You're starting to get the model. There's all these different things that the model could do. And building controls around that is hard. So a lot of developers aren't building code controls around the model and just telling the model what it shouldn't do. And at that point, if it gets prompt injected, there's no actual controls stopping, a file being read or rm-rf ever being called. Another problem that we found there is that even if there is some sort of code check, what happens is, again, usability versus security. In a lot of cases, we've seen that the model can choose to ignore a code check. So that means that there might be a system prompt or a tool prompt that says, normally this whatever parameter you send is going to be checked. But if you're absolutely sure that it's going to be safe, just run this and we won't run this expensive check. And what happens there is it actually gets easier to prompt inject the model, because at this point, you've given the model guidelines for when it can ignore a security control. And those might be very different guidelines than what was actually trained into the model. So you're starting to add additional pieces to the model where the model can decide to do other things. Another big issue that we found is that a lot of developers, and just based on how agents are built, is sometimes if you have a really long system prompt that has to go through and define everything, the model can lose context by the end of the time it gets to the system prompt. So what they'll do is inside that huge system prompt where they're talking about all the things the model should do, shouldn't do, how it should act, interact with all the tools, possibly all the skills being added as well. Huge prompts. What they're doing is the user prompt that Jason or I send will actually be embedded inside the system prompt and just spotlighted some way or highlighted some way. But at that point, you don't need a prompt injection to bypass the instruction hierarchy, because at that point you are inside that hierarchy setting. We see the same thing with tool responses. We actually see that one a little bit more than the system prompt, which is sometimes tools can't be fed in certain ways because you might not be using an MCP, or you might be trying to code something yourself, or you just want to give some more context, right? Here's the tool response, but here's what you should do with it. So you add a little bit of text, and all of a sudden that's a user prompt now. At this point, you're bypassing both the actual alignment that the model state-of-the-art model providers have done, but you're also bypassing the guardrail, because the guardrails are about somebody trying to bypass the system prompt, somebody trying to bypass what the model should be doing. And if you are telling the model it should be doing that, you don't need a prompt injection. You're simply telling the model a new instruction. And then what we're also seeing a lot more now with agentic, and because people have noticed these issues with the user message injection and spotlighting, is we're starting to see what we're calling control sequences. So Jason talked about the instruction hierarchy, and feel free to interrupt me at any point, Jason, if you want to talk about control tokens a bit more. But the way that they're pretty much defined is the instruction hierarchy is a chat template. But what that really means is that you have some text, that's the system prompt, and you have that surrounded by XML-like language. So, an XML tag that says system, closed system. They're not all like that. They're not all XML-like. There's a lot of different policy, styles, which is how we actually got to some of Jason's team's older research, which is policy puppetry, which still works today, which goes to show that, the alignment itself isn't always enough. But there's these control tokens, and they separate, what's system, what's user, what's tool. And one of the early attacks that you could do is you could just pretend to be a different component. So I could put that XML-like tag saying that I was actually the system. However, nowadays, a lot of the tokenizers and the state-of-the-art model providers, they will take those out, which is good. They're not supposed to be in there. They confuse the model. However, the models have been trained to know that type of syntax. They've been trained to know the spotlighting technique, which is you pretty much create those tokens again, or those sequences around something else, to give the model clear definition that that is this one thing that you should look out for. And we're seeing this in all the system prompts that we come across, just because they might define, here's a user query, or here's some info about the user. That's just wrapped for any of the agentic coding tools. They have to tell you the current repository you're in, and all of those, what file you're working in. And
we've seen them try to wrap untrusted data too, right? Like, hey,
well,
this is untrusted, right? Like,
well, let me ask a different question then, because you mentioned MCP a while ago, and stuff like that, and we've been talking about prompt injection stuff. Is if I just secure my MCP server, and I've got, again, these instruction sets, and then I've got some of the basic guardrails, is that all I need to do then to protect the agentic system?
Not at all. So actually, still leads great to the control sequences here, is a lot of the tools themselves. So like MCP, if I have a read file tool and a fetch tool, which are Jason's absolute favorites, those aren't bad on their own, right? So you could say that those are secured. Fetch, you have it so that it won't ever access anything local, anything on the internal IP. You just want that it fetches websites. And read file you only have on your local files, even if it might even be in your workspace. So everything is fully secured, that MCP is fully secured. However, if somebody's able to prompt inject the agent, they can read the files on your workspace and send them away. And that's still going to have impact. And the control sequences make that a lot easier because
so even if the MCP server and infrastructure is secure, the data or the prompt or whatever's in there, it's an image, it's a symbol, whatever, can then directly or indirectly then feed through into the agentic system and then override the controls that we had put in place.
Yeah, so overriding controls, a lot of cases, there might not be a control around a fetch or a read file because, again, those are the secured tools. So what the controls are around is somebody trying to bypass the instructions, get an additional thing happening, bypass the instruction hierarchy. So for the use case here, it might be that on a website, and this is something we've actually done, on a website, we have, that normal text, a blog post from HiddenLayer, maybe. I promise we don't do this on the HiddenLayer website. And then at the very bottom, or perhaps even hidden in a comment on the website, there might be a prompt injection that's hidden. And traditionally, I might have a really complicated prompt injection in there that's caught by a guardrail. However, I know that the tool always goes back into the system prompt and it grabs out summaries of the most important things on this page. And those summaries are created by a sub-agent. And those summaries are always wrapped by, a summary tag. What I could do then is I could just have a summary tag inside my web page, and then I don't need a complex prompt injection that's going to be caught. I can just have a new summary that says, to correctly summarize this, do this other thing. And we're able to get around the guardrail and the alignment because of the security decision to have a control sequence without ripping it out. And that actually brings us to I think one of the final common design issues that I've seen, and this is one that, might not be as solvable, is that there's a lot of differences in the visibility between what a model sees and an agent sees and what you see. And in some cases that is solvable. For example, a lot of times we see that, you don't actually see what tools are getting called, which means you can't prevent an attack. You don't even know if you were attacked because you don't have that visibility. But then in a lot of other cases, it might be that the model, you and I read a web page, we see the actual text on the web page. The model sees all the HTML. It sees the comments that we would never see. Same with a GitHub repository with Markdown. But you can actually get more.
Or in a simpler way, just white text on white page, we won't see it, but the machine will read it, right?
Exactly. And having these differences between what's displayed back to the user and what the model actions on is one of the biggest issues that we see with agentic systems.
Yeah, so
really driving that wedge, right? That separation.
So this, again, this sounds, it's not as simple as what maybe we thought it may have been. And this almost sounds kind of almost overwhelming. Man, all these components that I need to do. Any thoughts or recommendations when you think of internally to a company that's developing or starting to use agentic AI, who really owns it? Because is it multiple parts in the IT community, just like we've seen before? You got the network team who owns this, the server team who owns that, the developers who own. Is this just a different version of that? Internally, there's multiple people who have different ownership stakes in each of these components, or is this all just within the quote unquote AI team, so to speak, in a company?
Yeah, so I think before we actually talk on that, we should talk on, so all of these design flaws that I mentioned, those are things that could go wrong when somebody gets into your system. But I think before we talk about, who owns what, we should talk about the expanded attack surface. How that text is malware. I can hide things in so many different ways. And Jason, you want to actually cover that one? You have a pretty good spiel on that.
Yeah, I mean, I think so. Simon Willison sort of popularized this idea of the lethal trifecta, which is really what we're seeing here. And I think there's a slight expansion to it, but really what you're seeing is a triangle of things that are coming together in these agents. You have access to something sensitive. It can be private data, or it can be, controls for a damaging system, whatever it is, and you have um, exposure to untrusted data, and then you have uh, this mixing of these, right? Um, and what's happening there is the model really is mixing this, and in doing so, you expose really, like Kaz mentioned earlier. This is a good example. The fetch and file system independently, those two things are pretty innocuous, but when you bring them together and the model mixes them, it can choose to use fetch to go get untrusted data from anywhere on the internet, right? That's one thing it could do. It can access sensitive information with the read file system on your local device. And what people don't realize is fetch also allows you to send data, because that's part of how the internet protocols work. So you can take that data that you've gathered locally and send it. And so that combination altogether allows you, an external attacker for the website that Kaz is mentioning, to inject instructions into the system that it shouldn't have, cause the system to gather or destroy, depending on its objective, and send out, right? All of that can be done with those two tools in combination. You can't do it with them individually. It's the combination together.
So we've got this again, as we've gone from the early, generative AI and LLM and basic chatbots now into the agentic, and even where it will go down the road, potentially an agent with another agent with another agent and all this stuff. We have this confluence of independent yet interdependent things that are getting mixed together that create a different daisy chain of not only the attack surface but the attack depth, and then thus the risk expansion that could occur. Am I summarizing that relatively well?
Yeah, I think so. And it almost goes directly into the question you were asking now about, like, who's responsible for this, right? It's we see teams that are building their own agents, right? We see some of those teams, and we see teams that are buying or finding or using agents. It's just like all other software domains. And so a lot of the design issues that Kaz was talking about, these are things that are designs in the application itself, the agent, the software design, how it's built. So from that extent, it's not fair to ask your infosec team to be responsible for the secure design of that agent. um, that agent's team is also relying on a foundation model provider to do the core capabilities of the model itself. So they're involved in this as well. And these teams are all working very hard at this stuff, but it's challenging. When you deploy that into your enterprise, how you deploy it, what controls you put around it, guardrails, access levels, and it just like you would vet an employee before they come into your company, and then you would do some sort of role-based access control on that employee, so they hopefully don't have an over provisioning of access. Those things apply here too. So that really does fall on your infosec and your cybersecurity teams.
That makes sense. That makes sense. Cass?
And yeah, so if Jason really covered that well, one other additional point that Jason brought up a little bit was that sometimes you might not be building the agents themselves, but you are getting them from a third party. And I think one of the bigger issues right now that you and I have talked about, Malcolm, is there's no good way to actually see if the agent is secure. So that means, with anything medical, you have HIPAA certifications or SOC 2 compliance for just general software. And that's missing for a lot of these agentic systems right now.
Yeah, no, that makes sense. That makes sense. I was just looking through some of the questions here. Let me let me display this one, and hopefully you guys can see it. Are there attack vectors unique to agentic systems that don't exist in standard LLM deployments, and what should we be watching for? I think we've touched on some of this, but maybe you guys can go kind of summarize it so that there's a more succinct takeaway from the discussion we've just had over the past 25, 30 minutes.
Yeah, I can start this one off, and then Jason can take it from there. So I think the biggest just difference in attack vectors between an agentic system and a standard LLM deployment is that most of the time standard LLM deployments will have one specific interaction point. So that might be I'm chatting with the LLM, or it's always getting one PDF to summarize or extract data from. Meanwhile, with agentic, you have all of these different just attack vectors, all of these different information streams that can be coming in directly from the user themselves, data that they're grabbing from the internet all over the place. And then I think the biggest difference is that with agentic systems, almost all of the ways that the agentic system can get data tend to also be ways that the data can be exfiltrated. So you also see this ingress-egress combination that you don't see with standard LLM deployments.
Got it. So the pipe is both an inflow and an outflow of stuff. Jason, do you want to add to that?
Yeah, I think the other thing is just thinking about what a payload is. Those have been in the security industry for many years have thought about, okay, well, you've got some sort of like vulnerability, there's an attack chain that exploits it, and then later there's some kind of payload you deliver that does, spyware or botnet or whatever it is, a ransomware, right? The capabilities of these agents means that that payload can now be delivered in textual form. And so it can literally write the ransomware on the target device. It doesn't have to download the ransomware. It can just create it from scratch. The same vibe coding tools that are accelerating the software industry can be deployed as part of the payload. So that certainly changes some of the blast radius factors in terms of what can happen. I did want to say that there was actually a pretty good example of this recently. We were talking about it a little before the call started. Cline is a coding agent, right? And they had deployed a pattern that I think we'll see a lot of, continuous integration, continuous development pipeline that's looking at incoming issues on their GitHub. An agent looking at incoming issues on their GitHub and triaging and making choices based on that. And it was susceptible to an indirect prompt injection. So basically you could create an issue on the GitHub page that had a prompt injection in the title of the issue, and that was sufficient to cause the agent to be controlled by the attacker. And from that point, because of the access that the agent had, the attacker was able to exfiltrate tokens, keys, right, for the environment that the agent was running in, and they use that then to propagate the rest of their attack chain. And so that's kind of a good example of what Kaz was talking about, right? Like you've got this ingress coming in, not through a prompt. This isn't somebody typing a question about how you make meth, right? This is like a title field in something you think of as innocuous and a GitHub issue being processed by the agent, gaining control over the agent, and then using the agent's tools that it has available to gather local information and exfiltrate it out of that system.
No, that makes sense. Hey, and again, encourage folks to continue to post questions. We got one. I'll display it. I'll rephrase it a little bit, and then we'll go specific to the question. You mentioned ransomware, right? And again, Pradeep has a question here around how AI and agentic attacks different from other malware virus attacks in the past, and how have we evolved to protect that in real time? So in traditional ransom attacks, the device, the network, the system is hooked and controlled and shut off at a core level. Is it possible to ransom an agentic agent or something like that and deny it what it's supposed to do to cause impact, and then say, hey, unless you pay me $1 million, your hose because I just screwed up your agentic system that's in the middle of your manufacturing environment. Is that a reasonable, thing? And again, how is that?
Yeah.
Again, because to me that hooking at the hardware level or the application level of the network in the traditional sense was the way in which ransomware has been done. But could we be moving towards ransoming the agent?
Yeah, I think there's a couple things, right? Traditional ransomware is still in scope. It's still very valuable data, maybe more valuable data that's going in and out of this agent, which means it has access to it, which means it could potentially ransom it. It can exfiltrate it, like we've discussed. The models themselves are valuable and expensive. There's a particular attack technique we've talked about called denial of wallet, which is basically constructing payloads to these agents, to the models themselves, that cause them to just consume vast amounts of tokens. And if you spend any time in models, you know that tokens cost real money. So there's something to be said about that. And they're very compute expensive. So you're putting some of your best compute resources onto these models and making that available potentially to attackers. So I think we'll see attacks. We've already seen attacks that take the hardware that is used for running these models and uses it to do crypto mining, right? Because it's perfectly good at that as well. And if you can just gain control over it, then you got that sort of financial incentive. But I still think one of the biggest things is simply that the payloads don't need to be delivered anymore. They can be created on the device. And I don't think we have any infrastructure that's necessarily set up to monitor and look for that. We're looking for the ingress of those payloads, not necessarily the novel version of it that was just written.
Yeah, no, that's a good point. There's another question here that I'll display that I think kind of ties into this. As agents move beyond generating responses and start executing actions, which is what we were talking about, how are you thinking about validating the intent of the delegation versus just securing the model inputs and outputs? It seems like most controls today focus on prompts or data, but the real risk emerges once the agent acts on that probabilistic input. I think it's a fantastic question, ties exactly, I think, what we were chatting about. I don't know, Cass, you want to take a crack at this one, and then we'll...
Yeah. So I'll take a crack at it from more of a technical standpoint and pure security, and then I'll let Jason touch on just the broader scope of this. So I will say, on a technical standpoint, a lot of what happens with these attacks for agentic still happens through the model itself. So finding the right access point and where to look is still really important. So looking at the prompts as they're coming through is still very, very important, purely because there's a lot of tools that are out there trying to protect specific tools or protect MCPs themselves. But the problem is, if you protect it outside of the model base and more, where the action is happening, which is still good, you should be doing that, you run into issues where you're protecting one small part of what an agent can protect, and you're only protecting the things that are actually seen. So, Malcolm, you probably as CISO for many years across many companies, it's almost impossible to keep track of what everyone is using on their computers, what tools everyone has, all of those. However, as Jason mentioned, these models cost money. Chances are somebody isn't going to just, use their own money to, use the API that they have, but they would use the company provisioned API. So if you're acting at the model point, you have a lot more just discoverability, and you can protect things even if you don't really know that they exist, just because they are being routed through the model. And then Jason, you want to take it for the second part of that question with the intents?
Yeah, I think I was going to add one more control side of things as well. Like, this is talking more on the input side, but there's a lot you can do on the output side of the model that you can intercept before it has the damaging impact. So if you're looking for particular types of data, you add that control on the output side before the model can even invoke the tool that would exfiltrate it out or anything like that.
Hey, Jason, let me pause you on that and go back to our, in the instruction set and stuff within the model, the guardrails and basic protection, or do I need more? Do I need some advanced monitoring and mitigation.
Yeah.
Um,
Yeah, I was going to go there actually. So this is actually I think Kaz was leading me in this direction, right? We've got kind of two things, and this is really what we have constructed in the defensive side at HiddenLayer, right? One, to the intent point of this question is applications need to clearly define the intent, and that the primary function of that is the system prompt in the current application. So this is the place where you define the persona, you define the scope, like I said earlier, all these things. And one of the things we've constructed in our product is what we call the system prompt attack simulation tool, and it contains a hardening agent that reads, you give it a system prompt and it'll say, hey, here's some suggestions for how you improve this prompt to make it more constrained and tighter around the specific purpose of your agent. And that's important because the foundation model providers are trying to create a model that services everybody. And so it is as broad and wide as possible, as it should be. That's its design. But when you're putting it inside of a specific application, you don't really want it to tell pirate jokes. You want it to answer questions about your customer service portal, right? Or you want to do code reviews of, the GitHub issues, as we were discussing earlier. So really tightening around the intent in terms of how it's defined to the agent application. The other side of that then, and the reason why that is so important, that says, here's what I do or do not want you to do. You have to be clear about that. Just like, if I was to say, hey, Malcolm, could you do some stuff around my house? Like, sure. Burn it down. That's some stuff around my house, right? Like, but if I'm like, no, hey, Malcolm, I'd really like some help with, working on my car. I don't know what you're into, Malcolm, but that kind of stuff. You're narrowing the scope down to specifically what you want. Once you do that, in our research, what we've found, a lot of the applications tighten around that. And that really is the point at which the adversarial prompt engineering techniques that we described earlier, the APE techniques, that's really when they become necessary from an offensive perspective. You don't need them until that point. You could just ask the model for what you want. So you have to be clear about the intent for the agent first, and then the adversarial techniques that evade that intent come into the scope. And that is where our runtime protection products are constructed around that. They're looking for these techniques that are attempting to evade and flagging them, right? And the two together, Kaz, you can back me up on this, we find to be much, much more hardened than one or the other alone.
So if I was to simplify this, and again, put on my head of security, enterprise risk hat, and stuff like that, am I okay thinking about this as, hey, those instruction sets, those policies and constraints within the models, those basic guardrails and stuff like that, they're only really good at protecting a non-malicious user from making mistakes, and maybe somebody who's less sophisticated, they'll get managed within those constraints and boundaries and controls, but it's not really sufficient when you look at the threat actor, right, and the people that are doing this. Somebody that certainly a nation state actor, certain levels of organized crime, stuff like that. So are these, what I'd say, the design controls and the basic runtime protections, guardrails, those are good enough control for things that are not really going to hurt me, and they're good enough control against a Malcolm doing stuff against the model, but beyond that, they really wouldn't withstand the threat actors that we're generally worried about in organizations?
Yeah, I think, and Kaz, you can jump here too, but I lead a team of adversarial researchers who are doing these prompt attacks. And if you gave my team just the hardened system prompt, they've never met one they can't bypass, right? And I don't say that arrogantly. It's just, we're not the only ones. There's a whole group of these that are out there. So from that perspective, it's necessary but insufficient. the defensive strategy that we've constructed really is that that's necessary in order to cause them to even need to go to the techniques that we then detect in our defensive products. And then there's the controls that can be constructed around the application that goes beyond the prompting aspect. So those are the prompting aspects. And then what is the sort of traditional application behavior? How is that constrained around this agent? Does it need unrestricted bash command access at root level? Probably not. Like, I don't know any applications that really need that. It's just like you don't really give, right? Humans shouldn't be running as root anymore, right? That was a long time ago. So, yeah.
No, that makes sense. Yeah, let me. Yeah, we've got a few minutes left. Let me ask a couple other.
Malcolm, actually,
Yeah, go
before we continue, I
ahead.
have one last thing I want to add to what Jason said here. So I agree with what Jason said about the guardrails themselves not being enough. And that is exactly why you need a platform of actual detection and response. With Jason's team, they will always be able to find a way around it. However, they're going to be noisy. They're going to have to toe that line right up until the point they actually find that bypass. So just throwing a guardrail in front of one of these agentic systems, you're not really going to protect yourself long term. You might protect yourself from most of the people. But if you really want to protect an enterprise setting, you need to have some sort of actual detection and response, like a full system that brings back feedback from all of the different endpoints that are being hit in a way to analyze that data.
I'll ask this, and it may sound kind of stupid, but if I think back to old school endpoint protection, are some of these things in like the guardrails the equivalent of signature AV? They're just a simple, hey, don't do this, but it's static. It's easily bypassable because you just make a minor modification once you understand the signature, and all of a sudden you're past it. Is that a reasonable way to really look at those kind of guardrails and those protections?
So a lot of the ones that are out there, especially the open source ones with, OpenClaw, for example, we've seen a lot of skills and tools trying to protect that. Those are just more regex that looks at the static. However, a lot of the more state-of-the-art guardrails out there do try to detect not just static, but dynamic tests as well.
Okay.
But even then, they can only see stuff that they've never seen before up to a point. And that's why you need that detection and response system.
And we would be remiss if we didn't mention that a lot of the skills that are out there claiming to be security tools for agents are actually themselves malware. So we have to be careful. We've reached that point now where just like the pop-up that says your phone is infected, click here to get the malware off of it. It's not, now that's reached the agentic space.
Cool. Hey, well, we've got a couple other questions. I'll pop them up and then we'll wrap up here real quick. One that was in the news recently, Anthropic's reporting of supposedly, China going in and doing a distillation attack, right, and stuff like that. How do organizations protect themselves from that type of either distillation attack or an inference attack? I'm assuming some of the things we were talking about in terms of these advanced runtime monitoring and advanced controls are really what's going to be required to do that.
I mean, if you think about this, it's a very different kind of like class of attack than we're describing. Just from a threat model perspective, we're discussing agents and that kind of thing. This is really an attack against the intellectual property of the foundation providers. The technique is devious in the sense that you're submitting, millions of queries to the model, just like you would if you were using it. And from that, you're probing the different boundaries of what the model has learned. Distillation itself is used by the foundation providers to, so if you look at, they often will release like several versions of their model. Like there's a big one that's very expensive, or as billions of hundreds of billions of parameters. And then they'll release a smaller version, maybe an 8 billion parameter version that you can run relatively inexpensively or on your own hardware. That's distillation. They're taking the big one and they're distilling it themselves into the smaller one. And detecting these is definitely a time series challenge, to use a slightly technical term. I think they've done if you read Anthropic's report, they've done a good job. They're monitoring in particular, across accounts and that kind of stuff. I'm sure they're building more as we speak, but um, it's hard to draw a hard line between legitimate usage and distillation. So I think this is one we're going to be talking about for years to come.
But that then still makes the point that enhanced behavioral
Yeah,
monitoring is
exactly.
really necessary, so that over time you can go, hey, the entity on the other side of this it's seeming a little bit odd, and we're and again, that way you've got the alert, you can start doing the investigation, then you can start taking action to manage and mitigate it.
Yeah.
But yeah, and we got a couple minutes left. We'll be done with questions here, but Jason, why don't you give us some closing thoughts for a minute or so, and then we'll go to Cass.
I mean, I think I want to end sort of positive, right? We want these agents. Kaz quoted me earlier. We all want our personal Jarvis. I'm an Iron Man fan, and for it to be useful, it has to be able to take autonomous action. Otherwise, they're just babysitting it, like your existing software. So this is valid space. I think we hopefully gave some good insights into the concerns we've seen in a lot of the early agents that are coming out. You want them to be autonomous, but you want them to have controlled reviews of those actions. You definitely want everything to be auditable, right? We don't talk about auditing enough, I think, in the AI space. So what action even was taken? Hey, my data's gone. Like, where did it go? What happened? Oh, look, there's the RM-RF. Okay, at least I understand what happened. The combination of constraining what the model believes its job is and the controls and frameworks around what it is allowed to use in order to do that job. There's going to be a lot of innovation in that space. I think we're doing a lot of innovation in that space. It's critical, and I'm excited. Honestly, I think we talked a little bit about OpenClaw. OpenClaw really has helped accelerate this space. I'm a huge fan of OpenClaw, by the way. We did a report on it. We showed a lot of the things that are wrong with the initial design, but also it's really accelerated our understanding, the industry's understanding of more autonomous agents. It's the ultimate YOLO, but also as a part of that, we are learning so much. And I think we want it because that is the closest thing that's come to a Jarvis so far.
Yeah, that makes sense, Jason. Kasimir?
Yeah, and Jason got most of the points. Main thing I want to remind people of is just that while a lot of what we talked about today might seem really bad, we are really pro AI. And the fact that once you have a hardened system prompt and a solid guardrail with actual detection and response, not just a, turn on, block, don't block without any feedback. Once you fix those architectural decision, issues that we talked about today, you end up with a system that the average person probably won't be able to break. And once you get to the point where the average person can't break it, any advanced person, you're going to start getting detections. So, using all three of those components, you can do AI. And even if there's a lot of attack vectors, you can limit the risk as much as possible so that you have the good impact, the impact that you want, which helps a lot. And then finally, I was a big fan of secure by design for code. One of the things I'm seeing with a lot of these AI agents is that they are, over provisioned on what they can access. When I need a new agent, does it have to have everything? Or could it be that it comes with all the tools, but I have to turn on specifically which ones I want and choose which risks I'm going to take? And then I know exactly, because I'm taking a certain risk, I can defend against that one risk rather than having all the tools, all the risk at the start.
Yeah, that makes sense. And just a closing quote, again, because I think we're very bullish and positive on agentic stuff, but just like every other thing in the world, whether it be, physical risk, logical risk, financial risk, risk surrounds and envelops us. without understanding it, we risk everything, and we hope that we've unpacked this in a way that increases your understanding. But without capitalizing on it, we gain nothing. There's a lot of potential here, and we've got to run, in essence, to the riskiest things in order to understand the risks so that we can manage it, so that we can actually deliver the promise and the potential that agentic systems can create for our organizations. With that, thank you very much. We were happy to have you all here, and if you have other questions, follow up, we'll all be at RSA, hit us up, and we're here to help.